Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey guys, on this experiment, a couple things to note. You're going to have to go to just phet.colorado.edu and you're going to find things there, and then just search for Gravity Force Lab, and then you're going to then do the things it asks you to do. But the hard part of this experiment comes here on part 2 here. You're going to design an experiment to find the best equation between the relation between mass and gravitational force. So if you recall, what you're going to do from like what we did in the past, you're going to create a table, right? And that table is going to have 2 variables, right? Force and distance, all right? And that's what you're going to want to, I would keep the mass constant. So you got maybe it'll be radius on the chart. So you got distance and you got mass 1 and mass 2, right? So these are the equations, if you will. These are the 4 things. But I really would encourage you to find the relationship between force and distance, or it might be radius, and find that out. And then you're going to plug that into Desmos. I know it says Excel, but use Desmos as I taught you how to use that. And if you recall, there are a number of different ways, relationships that can happen, right? You've got a no relationship, and then you've got a linear relationship, you've got a square relationship, you've got an inverse relationship. Remember, that's y equals 1 over x. This is y equals x squared. This is y equals, c times x. I'm forgetting my c's. But there is another important one that we never did talk about in those days, and that is this other one that you're going to find here. I'm going to kind of hand it. The graph is going to look kind of like this when you do distance versus force, but it's not going to be super awesome this way because it's what we call an inverse square law. So it's going to be y equals c over x squared. So I want you to see if you can figure out how to make that happen. So I'm just kind of giving you the answer, I guess, but I want you to see if you can figure that out. So you're going to plot that and see if that best plots that. So you're going to create a, in Desmos, you're going to plot this y equals c over x squared, and then that's going to be, you're going to print that graph up, et cetera, et cetera. And also you want to make a conclusion. So on the conclusion, you have to go back to what we've learned in the past about the full-on inclusions with evidence, claim, evidence, etc. So it's a full-on conclusion I want you to write, so make sure that you're writing that full-on conclusion. If you've forgotten how to do that, or remember there is a cheat sheet in Brightspace that you can look up where the claim, evidence, et cetera, how to write a good conclusion. I'll make sure that that's inside of the Brightspace linkages so that you can easily find it. Hey, we will see you in class. Bye. All right, you guys, this is this lab right here. So if you go to, actually, let me go back. You're going to go to phet.colorado.edu. You're going to search over here for Gravity Force Lab, which is this one. Click on play. Now we've got these 2 cats. When you're trying to do the mathy part, what I would encourage you to do is to change these to constant size and then make the masses as big as possible. That's weird noises. I don't know how to turn the sound off, sorry. And then we're going to move these guys over. And so right now they're at 1 meter. And what you're going to want to do is with pencil and paper, write down, this is the distance between M1 and M2 is 1 meter. And so you're going to have your distance is 1. And your force, you might notice these forces are the same. Write them down. I know there's lots of zeros, but go ahead and write them down. Then you're going to move to 2 meters and write those numbers down. 3, 4, 5, up to 10 meters and write all these numbers down. This will be 10. Lots of zeros, 6, 8, 0, or whatever. Then you're going to flick over to Desmos. You're going to click here, create a table, and your x's are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And so if I flick back to this one at 10,
can I copy this number? No. I got 6 zeros, 6, 8, 1. 0.34566 681. And if I flick back to here, I'll just do a few. 7 is 1, 2, 3, 5 zeros, 1, 3, 6. Which one is that? 7. You get the idea. So I've got these points on the graph, and if you see them right here, these are the green dots, right? And so you're not going to see any delineation because these numbers are so small. So if you recall, what you have to do is you have to go up into the settings menu, and on your x-axis, you want to go from 0 to that number, 0.1239 maybe. I think that's going to be good. Did I do these wrong? I did these wrong. I did the x's. So what you'll have to do is it's the y-axis that goes from 0 to 0.1239, and this goes from, x-axis goes from 0 to 10. Now let's see if that works. Maybe I need another 0. Yeah, maybe even another 0. There we go. Now we can start seeing. So you're going to have to play around with the y-axis, and what you'll do is you'll have a ton of different points that are going to come here. And I'm just going to go ahead and give you the equation. It's going to be y equals c over x squared. And add a slider for c. And then you're going to mess with the slider. Now notice I don't see the slider. The slider is going to be a number between negative 0.01 maybe and 0.01. All right, now we kind of see it. So if I drag this down, we're in the neighborhood now at this point. You may have to still adjust your negative 0.01s to 0.01, make it as, you know, whatever. And that's how you're going to find the equation for this line.